Welcome to the video demonstration of our project predicting the CO2 emissions in a vehicle. Team members include in this project G. Rohit, T. Saiteja, P. Suryateja, K. Pranit. Myself P. Suryateja, studying in third year of Computer Science Engineering at Bhagdevi Engineering College, Bulikonta. Now let's get on to the introduction. CO2 is produced when a petrol or diesel engine burns fuel, and this carbon dioxide is produced along with handful of other harmful gases, and then the CO2 is emitted through the car exhaust pipe. The amount of CO2 a car emits into the atmosphere is measured in grams per kilometer. Worldwide, the car emits carbon dioxide under 1 billion tons of CO2 each year, that in the sense around 2.5% of total global emissions. For example, a car with 90 grams per kilometer CO2 have good fuel economy, and another car with 180 grams per kilometer CO2 will use a lot of fuel. So the consumers will look for a vehicle which uses less fuel with fewer emissions in order to reduce their running costs. CO2 emissions. Carbon dioxide is released into Earth's atmosphere mostly by burning of carbon-containing fuels, decay of wood, and other plant matter. Carbon dioxide makes up the vast majority of greenhouse gas emissions from the sector, but smaller amounts of methane and nitrous oxide are also emitted. These gases are released during the combustion of fossil fuels such as coal, oil, and natural gas to produce electricity. CO2 is an invisible odorless gas. Photosynthesis removes carbon dioxide naturally, and trees are especially good at storing carbon removed from the atmosphere by photosynthesis to build their tissues. Carbon dioxide is also removed by the oceans in which CO2 dissolves. Other gases are also causing Earth's climate to warm, but CO2 alone is responsible for about 3/4 of global warming. In the 19th century, since human beings began burning large amount of coal as well as petroleum, the amount of CO2 in the atmosphere has increased drastically. This is the architecture of our project CO2 emissions in a vehicle. Now let's have a look on graph of annual CO2 emissions. In this graph, we see the growth of global emissions from the mid-18th century to today. Prior to the Industrial Revolution, emissions were very low. Growth in emissions was still relatively slow until the mid-20th century. In 1950, the world emitted 6 billion tons of CO2. By 1990, this had almost to 22 billion tons. Emissions have continued to grow rapidly. We now emit over 36 billion tons each year. Emission growth has slowed over the last few years, but they have yet to reach their peak. Solutions to reduce pollution from vehicles as well as engines. Do drive vehicles less. Drive wise means the way we drive can reduce emissions from our vehicles. Choose fuel efficient vehicles. Don't idle the vehicle. Optimize home deliveries. Use efficient lawn and gardening equipment. To complete this project, you need Jupyter Notebook for programming, which can be installed by Anaconda and Python packages. Saiteja will now continue the further process.
Hello, myself T. Saiteja from Bhagdevi Engineering College, CSCB. Let's continue the next process. First, we have to download the required dataset for our project, and next step is to import the required libraries such as NumPy and Pandas. The next step is uploading the dataset by using pd.read_csv command. Data.head will return the first 5 row values from our dataset. Data.tail will return the last 5 row values from our dataset. Data.head of 8 will return the first 8 row values from our dataset. Data.drop of model is used to delete the model column from our dataset. Next, renaming the column names. Data.columns will return the all column names present in our dataset. Data.columns, here we manually giving the name of the columns that to be renamed in our dataset. The next step is used to know the information of the data. Data.info will give the summary of the dataset, is the column names and data types, etc. Data.describe will return the important values for continuous column data. And next step is seeing the target nominal and numerical columns count by using np.unique function, and it will return the data types of that columns. And next is handling the categorical data and analyzing the categorical columns present in our dataset. Here we are combining the similar type of classes into one class, and it is used for checking purposes also, and that is done for transmission column and same as for fuel type column also. And next step is checking the numerical columns, and it will return the numerical data column names, and checking the null values. It will return true if any column is having null values or not, and checking the sum of the null values. It will return the sum of the null values present in the column. The bar graph shows the null values present in the data, and it is a bar graph representation of the data. And next step is the labeling the categorical columns by using label encoder, passing the columns through label encoding. Now representing the columns is that make. The bar graph shows the data in the make column. The next bar graph shows the data present in the model 1 column. Next, the bar graph shows the data in the vehicle class column. The bar graph shows the data in the transmission column. Next, the graph shows the data present in the fuel type columns. It is a bar graph representation of make versus CO2 emissions. The bar graph representation of vehicle class versus CO2 emission. And next, it is a bar graph representation of transmission versus CO2 emissions. Next, it is a bar graph representation of fuel type versus CO2 emission. It is the correlations of the data present in our data set. Next, correlations of independent features with the dependent variable, and creating the dependent and independent variables such as x and y, and splitting the data set into train and test, and building our model by using linear regression model, and fitting our model, and predicting the results by using ypred, and checking the score of our model or accuracy. Here we got 92% accuracy. Next, dumping our model by using pickle function. Next, our team member Rohit will further continue the next process.
Myself G Rohit, and let's continue with the Flask application. We are going to build a web application. Initially, we are importing the libraries, and importing Flask module is necessary. Next, we are loading the pickle file here. Model.pkl is our pickle file. Then we are routing to the HTML page, which is a home.html. In this HTML file, necessary code is written to design the web page. And we also link the CSS file to home.html file in order to style the web page. This is the CSS file written to look the web page good. And after that, we are routing our app to prediction function. This function takes you to the prediction page. Now again route the HTML page, which is index.new.html. So this is the index.new.html file, and the text requested is stored in an array which is passed to the model. Next, we again link some HTML files to the model, such as result.new.html, in which we write the necessary code for the web page. So this is the result.new.html file. Now this is used to run the application. Now we have to run the app.py file. Now open Anaconda prompt, and we have to give the file path of our app file. And then we should run the app.py file by typing python app.py. Then it shows an URL. Now copy that URL and paste it in the browser. Then it redirects to the web page that we created. Now click on the prediction button and give the values. After giving the values, click on the predict button, and hence the result will be shown. So here the result is CO2 emission of the car is 1151.63 is given. So thanks to our Pradipti madam for guiding and instructing us throughout this extensive project. Thank you.